Hey everyone, so today we're talking about something huge. It's some new research out of Google that could completely flip the script on how we teach AI. The inspiration? Well, it comes from the best learning machine out there, our own brains. Let's get into it. It really all comes down to this one question, right? You and I, we learn new stuff all the time, and we don't just, delete old memories to make room. We build on what we know. So why can't these super advanced AI models do the same thing? Well, it turns out the answer gets right to the heart of a huge problem that's been holding machine learning back for a long, long time. It's an AI memory problem. And there's actually a name for this. It's called catastrophic forgetting, which sounds pretty dramatic, right? But it's actually a perfect description. Think about it like this. Your brain is like a cup you can just keep adding water to. But for an AI, the cup's already full. So to learn a new trick, it has to pour some of the old water out. It forgets. Catastrophically. And look, this isn't some small bug. It's a massive, massive roadblock. This is what's stopping AI from truly learning on its own, from continuously getting better. Every single time you teach a large language model something new, you're rolling the dice on it forgetting something it already mastered. That's a huge problem. So if you want to solve a problem like this, where do you look for inspiration? Well, you look at the gold standard, the best learning machine ever created, right? Our own brains. And when you put them side by side, the difference is, well, it's pretty stark. Our brains have this amazing thing called neuroplasticity. They literally rewire themselves as we learn. On the other hand, current AI has what you'd call static knowledge. To really learn something new, you basically have to wipe it and start over. And like we just said, it suffers from that catastrophic forgetting. The Google researchers used an analogy that just hit so hard. They said that an AI with this problem is basically like a person with anterograde amnesia. It's stuck in the now, completely unable to form new long-term memories. Suddenly, this abstract AI problem feels very, very real. Okay, so that's the problem. It's a big one. How in the world do you fix it? Well, that's where this new idea comes in, a whole new way of thinking called nested learning. And the big idea here, the real aha moment, is that for years, we've treated a model's architecture, like its physical design and its training method, how it learns, as two totally separate things. Nested learning says nope, they're actually two sides of the very same coin. So what is nested learning exactly? Well, instead of thinking of an AI as this one giant brain trying to learn everything at once, you think of it as a system of interconnected, smaller learning problems, all happening at the same time. The Russian doll analogy is perfect here. Each doll is a learning task tucked inside a bigger one. And this is how it works. You've got these different levels, or layers, each learning at its own speed. The outermost doll, that's the core knowledge, it learns really, really slowly. Then you've got the middle layers for specific skills, learning a bit faster. And that tiny doll on the inside, that's for right now, the immediate context, and it's learning at lightning speed. It's a multi-speed learning machine. Okay, so that's the theory, and it sounds really cool. But what does it actually do? How do you put this into practice and actually build something with it? Well, this new way of thinking isn't just an idea. It unlocks a couple of really key, powerful new tools. We're going to focus on two big ones: deep optimizers and something called continuum memory systems. All right, first up, deep optimizers. So normally, the rules for how an AI learns are kind of set in stone. With this approach, the learning rules themselves can actually learn and get smarter over time. It's like upgrading the engine while the car is still running, making it way more resilient. And then there's the second one. And honestly, this is a huge deal. It's called continuum memory systems, or CMS. You know how we usually think of memory as just short-term or long-term? Well, this blows that idea up. It creates a whole spectrum of memories, with different parts updating at different speeds, just like those Russian dolls. It's an incredibly flexible and powerful way to handle memory. So, to prove that all of this isn't just talk, the researchers actually built a brand new model based on these ideas, and they gave it a pretty cool name, Hope. And what Hope can do is pretty wild. For starters, it's self-modifying, so it can literally change its own structure as it learns. It uses that continuum memory system we just talked about, so it can manage its own memory. All of this basically creates the possibility of infinite learning loops, an AI that can just keep getting better. All right, the big question, does it actually work? Let's look at some numbers. This chart here is all about common sense reasoning. The higher the bar, the better the performance. And, yep, Hope is clearly out in front. It's just flat out better at reasoning. But where it really shines is with memory. They ran this test called Needle and Haystack, which is exactly what it sounds like. Can the AI find one tiny fact buried in a mountain of text? And look at that. Thanks to its crazy advanced memory system, Hope just crushes it. It finds the needle when others can't. Okay, so let's step back for a second. What's the big picture here? What does this all mean for the future of AI? The main takeaway is this. Nested learning isn't just another model or some clever trick. It's a whole new playbook. It says the architecture, the structure, and the training rules aren't separate. They're one unified system. And that gives developers a completely new dimension to play with. And I think this final quote from the research paper just sums it up perfectly. The goal here isn't just a small improvement. The real endgame is to finally bridge that gap, to go from the forgetful AI we have now to something that truly learns like a human. Which, of course, leaves us with one last, kind of mind-blowing question to chew on. Is this it? With ideas like nested learning, are we looking at the first real steps towards building AI that can actually improve itself forever without ever forgetting? Pretty exciting stuff to think about. Thanks for tuning in.